Effective interest rates. Sometimes interest rates will have special offers. Nominally, the interest rate will say that it's 3.5%, but when you have a look at the finer detail, you realise it's not exactly what it seems. In this video, I'll be explaining the difference between the nominal interest rate, that is the interest rate that is generally stated, and the effective interest rate. This is the interest rate that effectively takes in how often the interest is calculated. $1,000 is invested at 8% per annum. We're going to find the total after 3 years. If we did it compounding annually, we'd get an answer of $1,259.71. If it was monthly, it'd be $1,270.24. If it was weekly, it'd be $1,271.01. So you can see that the more times we calculate the interest per year, the higher the interest is going to be. But there is a limit to this. It does converge on a certain value. So what does this all mean? The nominal interest rate for each of these was 8%. But effectively, we ended up with different values. The more often that interest is calculated will mean that you get more interest. 8% compounding weekly is effectively a higher rate than 8% compounding annually because it provides more interest. There are different ways of writing the effective rate formula. This is one of my least favourite ways that it can be written. It may look simple and elegant, but it has some problems with it. The issue is what the letters represent in the formula. The lowercase I is different from capital I. Capital I, as we know, represents interest. Here it represents the nominal interest rate, but as a decimal. N, rather than being the total number of periods, as it is in most formulas, here it represents how often the interest is calculated per year. Your total answer at the end gives you the effective rate as a decimal, and you need to convert it by multiplying by 100 to get it as a percentage. My preferred way of expressing the effective rate formula is this. It may not look as elegant, but all we need to do is plug in the values. We don't need to do any other converting. Now, I have introduced here the I% as the nominal interest rate, but here it is as a percentage. C is how often the interest is calculated per year. So why I% and C? Well, on our calculator program, you'll see that there's an I% and a C/Y. Whatever values that would normally put into these places, we can put into the formula on the previous slide. Look at this first example. $1,000 is invested at 8% per annum, compounding annually. When we substitute into the formula, the I% is going to be 8 and the C is going to be 1 because the interest has been calculated once a year. And we end up, not surprisingly, at 8% per annum. This time it's going to be monthly. So rather than C being 1, it's going to be 12 this time. And then we end up with an effective rate of 8.3%. We're going to do example 1 again, but this time it's going to be weekly. Given that there are 52 weeks in a year, C is going to be 52. Our effective rate becomes 8.32% per annum. At the beginning of this video, I said if $1,000 is invested at 8% per annum compounding weekly for 3 years, you end up with $1,271.01. To do this, we can use our normal formula. Our R is 8 divided by 52 weeks in a year. We end up with 0.154. Just keep in mind there's a lot of decimal places there that I haven't included, but I have included in my calculations that follow. N is going to be 3 times 52, so there's 156 weeks in 3 years. We can then find out our R value, which is 1.00154, and then we can finally work out our total amount of interest, which ends up being $1,271.01. We're going to do this example again, however, this time we're going to use the effective rate, which is equal to 8.32%. Keep in mind, I've rounded there the 2 decimal places, but in my calculations, I've kept all my decimal places. I'm going to use an N of 3 because the 8.32% is the equivalent of the annual rate. So when I work out my R, I get 1.0832, and when I put it into the formula, I get the exact same amount to the cent as what I did on the previous slide. So let's recap. Effective interest rate converts the nominal interest rate compounding at different rates and turns it into an annual interest rate. Once converted, this effective rate works like an annual rate. There are some limitations. The effective interest rate formula doesn't work with loans where there are payments. The comparison rate is a better measure in this instance. Thanks for watching. Please subscribe and hit the like button. Please leave a review and a comment. I'm not a financial advisor. I'm an experienced mathematics teacher with a passion for teaching financial literacy. Please read the disclaimer.